accordingly. So this is a Jupyter notebook again. What I have done is I've added this extensions, and perhaps if you guys want, or if you are not able to install the extension, I'll help you do that. Just to recap, what extensions gives you is a lot of extras that makes that facilitates work in the Jupyter notebook. So you get all the snippets, you get, I have integration with YLab. So you can actually write an application in the Jupyter notebook itself and run it straight using YLab, which is very, very convenient. But here, but let me go through it slowly. If you are creating a title, like for example, the heading of this, what I can do is I can use the markdown language. One simple way is markdown is what you are trying to tell the reader, whereas code is what you're trying to tell the Python kernel.
We can't see your screen.
Oh, you can't. Good, good. This is strange. You seem to be going back and forth. All right. Hopefully this time we'll be able to. Any luck now?
We can see it now.
All right. So guys, I'll just mention this. There is a language called Markdown. Markdown is as close to plain text as possible. It has a very simple syntax. In plain text, if you start a sentence with a hash mark, it is considered a title, heading. If you start with 2 hash marks, it is a subheading, 3 hash marks are subheading, and so forth. And then there is a way to put a list and so on and so forth. So for example, suppose I want to insert things here is a simple illustration of the use of profiling report to get automated exploratory analysis of the data set. Okay. So this is it. Now, right here, suppose I want to, do you see that the markdown is as a language? They are always helpers. Suppose I want to itemize something here. Right. What has it done? It has told me that I can have sublists and so on and so forth. So let me, topic covered, imports. I'll just write it just for the sake of writing it. The numerical libraries, NumPy, SkiPy. Then another one is, let us say, data frame. And pandas profiling. Data frame. These are the two things. Then we can have visualize plotting. We can have plotting through Seaborn, matplotlib. So just for the sake of illustration, I am putting some statements here. And the third is some overall configuration of plotting PLT next file, then PLT.rc commands. And do you see how simple this language is? It's not like HTML. Relative to this, HTML looks complex. And so what I do is, if it is a markdown, I run it. When I run it, do you notice that this has become nice, well-formatted text? So this is the part about markdown. It is as simple as that, a very, very simple language. And if you have the snippets installed, then it is extremely easy. You just go and pick whatever it is that you want to do. And This is also very LaTeX aware. Like for example, if you were to insert, you just double click on it, it will go back into the insert mode. And let's say that in that you want to insert an equation. And those of you who are familiar with that will remember that. So here it is. It has given an example of an equation. Now, I don't know if I've installed the math jacks, but hopefully. So now when I run this thing now, yeah, you notice that there is an equation here that has showed up in the documentation. So it's very convenient. Obviously, it implies that you need a little bit of LaTeX. And not everybody is familiar with LaTeX. It is something that has a learning curve. Unfortunately, there is no better way to write equations or syntax, mathematical syntax, than LaTeX. For example, the notes that I give you, I don't know if you realize, it has been written in LaTeX. Right? And the formatting is superior to what you would get if you were doing either Microsoft Word doc or Google Doc or so forth. So this is the advantage of using Markdown and having the convenience of all of these things quite literally in this. And then again, you have a lot of these things. Also, you can you can embed widgets. For example, if you want to put a button or a picture or anything, you can just directly insert widgets into this. But we'll do that later. And then let me start with this, the basic imports. I'm just saying here these are the basic import from above as code. This is again a markdown. So I'll change it to markdown and I'll run it.
Asif, can you write that particular code in another editor and bring it into
Absolutely.
Jupyter?
Absolutely. You don't have to write it here. You can
Okay.
write it in whatever you like and copy paste it.
Okay.
And sometimes you don't even have to copy paste if you want. Jupyter is very powerful. There are all these hidden powers. You can do all sorts of includes and whatnot. But today I'll stay with the basics.
Okay. Thank you.
So when you do things like this, here we have the import. Let us insert a cell below, and here I'll give it another heading. Let us say uh, two hash marks is obviously the heading. Load and load and describe the data. Load and describe, right? The data. Yeah. Since the columns are not mentioned in the original data set of sklearn, we add it manually. Let me just say, we add it manually. It's just a description. Do you notice that this is a heading and this is a description? If I change it to Markdown, once again, I can run it. It becomes section 1.2. You describe the data. Then now, suppose here I say insert cell above. Finally, let's do automatic data exploration query analysis using the pandas profiling. Pandas profiling, right? So this is profiling. Exploratory data analysis. I'll mark it as such, and obviously this is a very sort of a simple walkthrough. So here we go. We have put it here. Now, so this notebook now, it's a very basic notebook. It is made out of two elements, text element or markdown element, where the target audience is the reader. So this is this element where or this cell where my mouse is or highlighted, is it a markdown or is it code? One of you?
Markdown.
It's markdown. Right? It's markdown. And any markdown element or cell, like if you want to convert it back into edit mode, all you have to do is just double click on it. Right? And if you want to run it, just control enter will run it, get you back into execution mode. And to execute it, you can just keep hitting run like this, right? And something or the other here. Data frame iris. Data is equal to, I think I have data is iris and columns is equal to columns. This is like NumPy. So this code, let me just explain a little bit about this code. The, in your lab notes, I've given you the iris dataset already created. I didn't use, I believe this, I used the one built into scikit-learn. But there are many datasets which are sort of academic interest. Iris is, of course, the most famous of them. It is heavily referenced. It's perhaps the most referenced dataset in the machine learning literature. It's also the most basic that you can think of. There are four predictors, the flower's attributes, and then we are trying to determine the species of the flower from it. So a lot of these data sets, they come built into these libraries, the Scikit library. Speaking of libraries, let me give you a walk through the library. The, the ability to do matrix multiplications, arrays and matrix in a high performance way, that is done using the NumPy library. NumPy sits upon underlying Fortran library called BLAS, basic linear algebra system. You may wonder why sitting upon Fortran, why not implement it in Python? The reason for that is the performance difference between multiple reasons. One is the performance difference between Python and Fortran is roughly speaking a factor of 1,000. Fortran is the fastest language that we know of, faster than C, faster than anything else. That is one. The other thing is Fortran has had 40 years almost of investment. People have been writing in the scientific community. Predominantly, they write code in Fortran. Even today, a lot of scientific computing code is written in Fortran. And those libraries in 40 years have been perfected. They have been perfected with respect to bugs. Very few bugs. It's hard to find any bugs in them. They have been perfected with respect to performance. It's almost impossible to beat the performance of Fortran code. So what Python does is it sits upon those libraries. It has bindings to those underlying very mature scientific computing libraries. And those bindings are written as Python libraries. NumPy is the Python library that brings us arrays and matrices. And these matrices are very high performance. One question that people often ask is, why not use the list of Python that is just as good? Treat it as an array and so forth. The reason for that is when you, let's say that you want to multiply all the elements of a list of numbers by something, let's say 10, you'll have to, in a sense, do a multiplication, element-wise multiplication, even though Python may give you a syntactic sugar that makes it look as though you're just in one shot doing it. It doesn't what is called broadcast. Whereas NumPy, what it does is, even if you have an array that is massively large, because that array is actually a Fortran array, when you do a multiplication, it happens at the Fortran level, and it happens in a, usually, if you are on a good hardware, in a massively parallel way under the covers. So those Fortran codes will utilize everything that you have in your hardware. The next library here is the pandas. Pandas is what brings you the data frame. Think of it as a spreadsheet with rows and columns. That support is not built into Python. This library pandas brings it. Recall that in R, this comes built into the language. But in Python, you need to use this library. This pandas profiling is what we are using, a very convenient tool, as you will see. Makes a lot of exploratory analysis you would have done by hand. You're actually doing it with one line of code. It's a recent addition to the data science toolkit and very popular now. These are plotting libraries, these three, Matplotlib and Seaborn. Matplotlib is the oldest library. Everything is based on top of that. Seaborn is a layer on top of that. Seaborn is very tightly or sort of much more compatible with data frame, the pandas data frame. So between pandas data frame and Seaborn, you can have very good plots and visualizations quickly. The rest of these are just parameters we set. Like we say, this is just giving a theme, Seaborn dark gray. It's a theme of tables and visualizations. This is then we are setting some figure size when we draw the figures. It should be 20, I suppose, units by 10 units, right? And so forth. Some colors, blue, green, etc. These are the colors to use, but I don't think I'm using it here, but yes. Then import warnings, one of the things it does is when you run the code, sometimes copious amounts of warnings come out and sort of your notebook gets littered with a lot of warnings and things like that. So one way to suppress it is this. Now, one thing worth mentioning is, do you notice that when you run a cell, it tells you how long it took to learn, to run. You know, this 918 milliseconds and it finished. So that information is useful, you know, because suppose something takes 3 hours to run. And in machine learning, that's very common. Some of the tasks can run for 12 hours. So you will be hesitant in rerunning it, knowing that it's a huge computation. You would look at the execution time and say, do I want to wait for that to finish? Do I really need to run that? This helps you determine that. It also tells you when was this last run. So that's the explanation of the basic imports. One more library is the sklearn. Sklearn is the famous scikit-learn library. It is the de facto machine learning library in Python. It has support for everything except that when you do deep learning or deep neural networks, you tend not to use scikit-learn, even though it has some support for it. You tend to use TensorFlow, Keras, and PyTorch. Now, as we make progress in this workshop itself, and this is the first time I'm doing it, I don't know if it doesn't become too much for you guys. One of the things I was planning to do is that introduce you guys to deep neural networks pretty early on, those libraries, pretty early on in the lectures. In fact, as we do regression, one of the things I wanted to do is do regression using scikit-learn, which is the sklearn library here, and also do it using TensorFlow, Keras, PyTorch, etc. So that you have early familiarity with those for the whole toolkit, the whole tool chain that we have in machine learning. So we will do that in due course of time, but we are still in the very early stages of this workshop series. So that explains that. This is, what this does is, it describes the data. It tells you basic descriptive statistics about each of the features. The features are obviously the 4 features. The include all says that don't skip the categoricals if any. Here it's not really necessary because all of them are numerical. Now guys, do we know the distinction between categorical and numerical? Would anyone like to remind us? What is the difference between categorical and numerical features? Anyone guys?
Categorical is where we have a finite set of elements in that particular set or in that category, which can be represented by just finite values. That's categorical. And
Excellent.
anything that can be measured is numerical.
Excellent. So, excellent, Suresh. Thanks for chiming in. So, in simple terms, when you have a finite set and you have to identify one of them, so for example, you have a finite set of true false Boolean, right? So you have to tell whether something is true or no, false, right? Or whether, or suppose you have 3 animals, cat, dogs, and cows. And you have to identify which of the three animal a data point is, if I tell you the features of that. So that that set or or the values, when they come from a finite set, you say that it is a categorical feature or categorical variable. And everything that's quantifiable, that's measurable, is numerical. It takes on real values, rational, irrational, fractions, whole numbers, negative numbers, whatever, but those are all real values. They're measurable quantities. So that's the difference between that. Why did I call transpose? The reason is, if I so see what happens. In this particular case, if I remove include is equal to all, the reason I put include is equal to all is I wanted you guys to develop a habit of using it. But see, suppose I don't do it. I do a very basic X describe. Do you see? This is the standard form in which it shows. This for this data set, simple data set is okay. But if my input feature space had 30 columns, 30 features, you realize that there would be 30 columns here, and there would be a scroll bar at the bottom, which is a bit of a nuisance. So it is more convenient to put transpose. If I do transpose now and hit enter, you notice that the whole table has been rotated 90 degrees. And now even if I have 30 features, it will just be 30 rows in this table. I won't have to scroll horizontally, which is why this is preferred. And include is equal to all in this case will not make any difference. Will not make any difference because, well, none of the variables are categorical. Right? This is it. Suppose you want to find how many, this target variable, how many unique values are there. You can do that. And P unique, it tells you that there are three values, 0, 1, 2. Now, moving forward, you have this lovely, lovely tool. You just import pandas profiling and then say x.profile report. When you do the profile report, it produces something quite lovely, actually. And let me see if I can open it in some external view frame source. You can't load it outside. But okay, here we go. So what this pandas profiling does is, in one shot, it looks at your data and gives you a lot of information about it. So in the overview, do you notice that it gives you the statistics? There are 4 variables. Number of observations is 150. It tells you a lot about it. Are there duplicate rows? It turns out that there is a duplicate row somewhere here. Then are there missing values? For example, is it a situation that sometimes sepal width is missing or petal length value is missing or something? It says that the data seems very clean. There are no missing cells, 0% missing data. And then it does systematically explore the data. You're looking at univariate statistics. Sepal length is a statistic and it tells you all about it, mean, median, everything. Pretty much you calculated that above here, but now you see everything coming out automatically for you. You also see a frequency plot. Frequency plots are called histograms. You see the histograms here. And if you toggle detail, you see more of that. So in statistics, you can see the quantiles. You can see a lot more detail, right? You see the standard deviation, the coefficient of variance, a lot of these things, kurtosis, skewness, and variance, and so forth. What these things are, at some point, I'll be explaining to you, but if you're curious, you may have studied it in your high school. I may not have. Most people have not, and even if they have studied, they forget about it. These are called the moment, first, second, third, fourth moment. The first moment is the mean. The second moment is called the variance. The third moment is called the skewness, and the fourth moment is called the kurtosis. Right? So they are descriptive of the data. Let me give you an idea. If you look at the data, do you feel that does this graph look to you symmetric? Anybody? Does it look
Yes.
symmetric or does it look slightly skewed?
Very slightly skewed.
Very slightly skewed to the right, right? Right skew is considered positive, and you can see it here. The skew value is a little bit positive. Right? Then the mass of, does it have a long tail or does it not have a long tail? Well, it doesn't seem to have much of a tail at all. So kurtosis is somewhat light, right? minus 0.55. Kurtosis is a measure of how heavy the tail is. What it means is, for example, when you purchase things from Amazon, if Amazon were to look at a table of all their items and how much they sold, you would realize that there would be a few bestseller items which sell a lot, and most of their items sell maybe what 100 items a month. Right? So they have a long tail of millions or hundreds of millions of items, which have small amounts of sale, but it is still profitable. So in those cases, the kurtosis value would have been high. So that's the meaning of kurtosis. Let's look at a histogram. As you can see, the same histogram has been made like this. It is also a dynamic histogram, winning strategy, Bayesian blocks, and so forth. So a lot of this, is too much detail at this particular moment, but it is still nice to know that they exist. How often are certain what are the most common values in the data? It turns out that it is sepal length tends to very often be 5. The next most frequent value seems to be 6.3 and so forth. So it just gives you some things. Extreme values, like what are the values at the extreme ends? Well, these all seem to be values at the extreme end. They seem to be the low values, I suppose. Or is it the high values? Hang on. Statistics. Minimum is 4.3 and max is 3, 95th is yes. So this seems to be on all the small values, 3 small values. And extreme values. So maximum, minimum 5 values and maximum 5 values. This is it.
What is sepal length?
Come again. This is all just for sepal. So you realize that this tool has given you a lot of facts, which otherwise would have taken you a long time to compute and write code and come up with. And the same thing it does with sepal width. I won't go into it. You can toggle the details and you can go to petal length. What it is saying is that petal length has high correlation. It observes something. It says that there's a strong correlation between petal length and if you click on this, petal width. Here also it says these two are highly correlated. Something interesting, and we'll come to that in a moment. Once again, for each of these, you can look at the graphs, common values, and so forth. So I won't go too much into that. Let's look at the interaction. So is there a relationships between these? So it is getting into too much detail at this particular moment, but let me not get too much into it. The most important thing is correlation. This correlation plot, you see that if you toggle description, it will tell you what it is. I have taught you only Pearson correlation. At this moment, you can stay with that, but if you are adventurous, you may want to learn about Spearman's correlations and rank correlation, then Kendall's, which is also a rank correlation in phi. So there are multiple correlations that are used in the industry. By far, for numerical variables, the most significant and most often used is the Pearson correlation. So let us look at the Pearson correlation. We realize that if it is dark red or dark blue, it means strong correlation. Let us see what we see here. Petal length, do you see it's strongly correlated with something, petal width and petal length? Yeah. This is dark red. What does that mean? It's on the scale, the sidebar, if you look at the color bar, it means very high correlation. Isn't it, guys? Right. Likewise, there's a very strong correlation between petal length and sepal length. These are all high correlation areas. Right. What are the negative correlation? It turns out that petal length and sepal width have opposite correlation. The bigger the petal length, the smaller the sepal width. In other words, in iris flower, if it is long and slender petals, the sepals will not be wide, which if you know iris makes sense. So it's a way to see correlations here. This tells you, are there any values missing? Now in this very, very clean data set, none of the values are missing, right? All of them are present. But this plot is of great value when you get large complex data sets. For example, the California data set that you have, one of the things to study there is what is the missing value analysis there. And you'll be surprised what a rich graph you'll get there, plot you'll get there. Right? And you'll have to have some strategies to deal with that. Anyway, so it checks for missing value. Huh? And then, of course, this is just some sample of the data. So this is your overall, and this is what you call your profiling. Very rich. I would highly recommend that you use this wherever possible, but don't become totally dependent on it. In other words, you should know how to do it by hand, how to draw the histogram and so forth. So if you notice in the notes that I gave you, I have deliberately used both syntax. For some data sets, I have used automatic automatic or automated exploratory analysis. For some, I have given the whole analysis, the code for how to do the whole analysis. Likewise, in the notebook, I've deliberately switched between R and Python, so that you become familiar with both.
Asif, just one question here. On this tool that's good, not directly related to what we are doing, but let's say the data set that we are analyzing to do the EDA is like a billion rows, and I know it's going to just hang when I try to give these comments. How do I approach those kinds of data? Is there a different way I should approach those?
Yeah. See, here's the thing. We are not able to grasp a billion. Even if the tool could load a billion rows, you would realize that your eyes will simply glaze over. Right? What you do is first define your problem and then take a sample. Sampling is easy.
Okay. Mm.
Just take a sample and be careful that it is representative sample. And there are sampling strategies, but let's start with simple one. Just start by taking a random sample. Right? Now, random sampling gets into a bit of trouble when there is a huge skew of data. Let's say that, you're looking for the blood test results for a rare disease. Then most of the data sets will be for healthy people. And there may be just 4 data points out of million for that rare disease. So if you randomly sample, you may not catch the rare disease. The data set, the data instances for the rare disease. So in such situations, you have to be a little bit more careful. But in general, at the very basic level that we are starting, just take a random sample and start. Generally, the law of large number holds, which essentially says that once you have a sufficiently large sample, it is representative enough of the larger reality.
Okay. Okay. So the lesson is the sampling would work best if the rows are limited and you can understand exactly the ins and outs of the data.
Yeah.
That's where it makes sense.
And here is a rule of thumb that I use. I'll have to think why I use this, but I've used it now for almost 25, 30 years, and it has worked for me. When you have a lot of data, see big data in the industry, in the commercial and the public world is just coming out. But in my world, uh, as some of you know, after IIT, I was doing a PhD in theoretical physics. So in particle physics, we used to get massive amounts of data. We knew like sort of big data on a giant scale. So basic rule that I used to follow is, suppose your data set size is like you took a billion, right? What
Mhm.
square root of a billion? 10 to the 9, isn't it?
Yeah.
So let us
Yes.
say it is 3 into 10 to the 4.
Mhm.
That is approximately 30,000 rows.
Right.
So these
Mhm.
tools will easily handle 30,000 rows. And generally, I find that unless there are, class imbalances and other considerations in the data, generally taking the square root of the value for very large data sets is quite representative.
Okay.
That's
Okay.
the rule of thumb I follow. I'm sure there's a mathematical way I can justify it, though at this particular moment, it sort of is escaping my mind. I've followed
Okay.
it for so many years, but follow it. I mean, just take it as one practitioner to another, that it works.
Yes. I will trust that. Yeah, I'll take that. Thank you.
So deal with that. So this is it. So now, guys, I want to show you something. This is a very simple notebook. I trust I've given you guys the notebook. Suppose in this notebook, I want to generate a table of contents. Right? What do I do? I click on this. Do you notice that on the side, table of contents are coming? So does it make it very easy to scroll and understand this data or this notebook? Do you see this, guys, where my mouse is going?
Yeah.
On the left, right? So it is quite useful to be able to do that. Right? Very convenient actually to be able to do that. And you can do more things. You can insert a table of contents, etc., etc. The very top of this. I wouldn't go into it. It becomes a little bit littered after a little while. And you see that as you get more and more familiar with things, you will see that there is a lot going on. Those of you who are used to Emacs, for example, my fingers are used to Emacs. So I can switch over to Emacs keyboard bindings. Sublime text is very popular with people. You can switch over to Sublime sort of a key binding. Vim is again a VI editor. If you're used to those key bindings, by all means go here. Right? Then you do you notice that there are many, many things you can do. There are toggles for all of them, show labeled anchors, etc., etc. Many things, equations, bibliography, latex environments, and you can keep on adding things to it. One other lovely thing that you can do is the themability. There are some Jupyter themes. Anyway, this is just starting, so I'm mentioning these things that many people ask that they don't like the white color late at night when you're looking at the screen. White is very jarring. So you don't have to stay with that. People like dark themes. Well, there are these themes. You can go and look at this. Right? Do you see these dark themes? So there are many Jupyter. So all you have to do is install the Jupyter themes. That's all. Pip install this command is all you need. In fact, I don't think on this Linux machine I've installed Jupyter themes yet. Why not? Let me go and do that. So I'm going and doing that, and sure enough, uh, Jupyter theme has gotten reinstalled. And so if I were to go and do kernel restart, hopefully somewhere I'll develop the ability to now go and change the theme. Actually, no, I can't. I'll have to restart the whole Jupyter with the theme. There's a way to configure the theme, and that documentation is here. JT, Jupyter theme, and you can change this. How do you change the theme? And there's many, many configurable things. For example, obviously I have not done it here, but I tend to use more textbook font, the old style text font, something that looks better in textbook on paper than in the notebooks, because quite often I tend to print my notebooks on paper and then read it in bed, for example. So for that, you can change the fonts. You can specify what your font choices are, and everything is highly configurable. You can do what you want with this. So I invite you to play around, guys. Jupyter is something you're going to spend a lot of time with in your career. Might as well get used to it. So this was one data set. Now, this thing, suppose you want to export to HTML, you can do that actually. See, download as, you can download it as PDF. You can download it as HTML, as LaTeX. The LaTeX isn't, I wasn't too impressed because it's rather noisy, but it's there at least. You can make it into slides. Actually, I've never used the slides. Maybe I should. Maybe we'll do it together. All sorts of formats you can export it to. So for example, if I do HTML, which is the simple, right, with table of content, let's see what happens. Here it is. It has generated that. And you notice that this, by the way, is a HTML file with a table of contents on the side. And now you can just publish it on any web page that you want. But now it is not a Jupyter notebook. It looks like it, but it is actually an HTML export of that. You can do other things you can do. Let's try another thing. You can do PDF. For PDF, you better have LaTeX on your machine. But if you have LaTeX or text, which I talk about in my notes, do you see this, guys? Does it look like a PDF now? Can you guys see that? Anybody?
Yep.
Yeah.
Yes.
And you can see that the fonts are very paper friendly. This is the standard Roman font, the nice fonts. And this entire thing has become, well, a PDF through LaTeX. Likewise, you can do, let's try something that I've never tried myself. it would be an experimentation for me. I don't know how I can do this slides. That should be fun. Let me do that. Oh, Irish slides. Look at this. This has now become, the outline of this has become slides, right? I suppose. So quite a bit of functionality here, huh, in Jupyter. And you can keep on adding it. And tab 9 and many more things can be added. You can highlight some things. I wouldn't go into that. Navigate. So actually, I have not. This is a new machine, so I've only added a couple of plugins. There is more to add. Now, I'd like to go on and take the next easy data set systematically, the weather data set. Oh, by the way, this one, should I also do the Python, the R version of it? I believe this is the R Markdown version. Yeah. So the same iris, doing it in R doesn't make it harder. But in R, I chose to do it by hand. Like, not to do it using the automated data exploration tool like the pandas profiling. In R, that is called the Data Explorer. If I use the Data Explorer library, it will have a similar effect as using a pandas profiling in Python. But here I chose to do it quite literally by hand. And when you do it by hand, you see the results here. And I believe I mentioned this in your notebooks. These are there in your notebook somewhere. So one thing is that how do you load the data? It's very simple. What in Python was described is summary, produces the same median, min, etc., etc. Looking at the first few rows of the data. Now there is a library that is very, very useful. It's a collection of libraries called tidyverse, and it sort of centers around the concept of tidy data. Both pandas and has a good support for it. And in R, of course, this is where it was created. The whole movement for tidy data was created in the R community. And what it does is this library makes dealing with data look almost like SQL, very simple data manipulation language. Do you notice that you take Iris, you pipe it? This is sort of the Unix, just as in Unix, those of you who are familiar with Linux know or are familiar with pipes, know what I'm talking about. This is the pipe symbol. Means you take this data and you give it to this. From this, you deselect a column called ID. Why? Because this ID column here looks useless. So you deselect the ID column and then you rename some of the columns. You notice that select. So now these columns remain. These names look pretty bad. Right? So you rename the columns to be better, right? Better names. And then you will see me use tidy data format and this dplyr syntax, this pipe syntax, all over the place. This is a way to pretty print a table. Right? I could have just printed and shown it. There are many libraries, two libraries in particular. One of them is the Cabal, and the other one of them is called the Table Extras and Grid Extra, I think. They're very good libraries to create beautiful tables, especially for publication. Now you notice that I managed to highlight this particular column. Why do you think I highlighted the species? Because it's the target variable. Right? It sort of makes sense to show that this is separate. These four columns are together as feature space, and this is the target space. And that's what I was trying to do. And this way of dealing with data is very powerful. So those of you who are used to C, Java, etc., would realize that suppose in this data frame, I want to quickly find the median of each of the feature variables. It would be quite a thing to do. You'll have to write a bit of Java code, a C code, and so on and so forth. But in R, and obviously also in Python, in these data science languages, these are all one-liners. First, what you do is you group the data by species, and then for each species, the group of data points for that particular species, you just find the median. You see me doing the median. So this syntax, guys, I hope you will remark at how powerful and how very simple it is, how much you can achieve with just a couple of lines of code. In fact, this would be considered one line, even though I've broken it up into many lines. It is quite literally one statement. In one single statement or assignment, you were able to find the entire summary of the data. So, and in one single shot, I'm able to also um, represent it. Yeah, you notice that. Now, then plotting it. Plotting the iris data again is a straightforward thing. Now here I am using yet another library. So I used iris to actually just introduce you guys to the various libraries. One library for visualization that is heavily used is ggplot. I talked about it in the book, which is the grammar of graphics thing. Right? It systematically builds up any visualization, however complex. So you look at this visualization. Does it look complex, guys? First of all, it's a grid. Lots of things are happening. Diagonals look differently. Diagonals are something called density plots. The lower cells here, parts are all they are all scatter plots. Do you see the scatter plots? Not only that, there is a best fit line, a linear regression line going through them. And there's a line going through for each species of the flower. These are the contour lines of KDE. They give you the contour map of the data. So a lot is happening in this particular graph. If you were to do it without using a systematic method, or for example, if you were not using ggplot, just using normal plotting library, this would be reams and reams of code. And if you search in the internet, quite often you find people have written the reams of code, etc. But actually, there's a very simple, nice way of doing it. Um, One thing that I use is ggalley, which is a lovely thing for representing things like this. But here I'll go, it gives you this pair plots. It is an extension of ggplots. And then there are themes. Uh, I'm just introducing these concepts here. ggalley helps you make pair plots in Python, I mean in R and the other libraries also. It is just prettier than R's native pair function. R comes built in with a function called pairs. The output of that is pretty rudimentary and not as rich as that. So let me explain what all things are happening here. First of all, this is a grid plot. Secondly, you notice that I've themed it, and I'm using a theme called Tuft theme. Edward Tuft is a Stanford professor, and he started a very influential movement where he said that let us stop being silly when it comes to data visualization. For example, when we make a bar chart, there is no reason why a bar chart should look three-dimensional. It should have a color gradient, and it shouldn't look like eye candy. Use the ink to convey information, not to just prettify or do things. Most of the ink in the plot should go to showing the data itself. And so he is not too much in favor of having a lot of grid marks, three dimensions, and all of that, but simplicity. And that is quite influential. He has written books like the visual display of quantitative data, which is a very, very influential book in data science communities. And obviously, he also gives this very popular workshops. You guys are welcome to go attend it. He's written many books now. So influenced by that, increasingly people are adopting the Tuft style in their plotting. And in fact, the notes that I hand out to you, the notes themselves are adhering now to the Tuft book style. And more textbooks now in the community, in the scientific community, are being patterned after Tuft book uh, recommendations. So it matters. So you notice that in one line here, we are able to do so much. We are able to give it a theme. We are able to specify various thematic elements like what is the size of the font on the left and size of the font, these numbers and so forth. And let me walk you through. First is what is the data? First layer is the data. Then you specify what is it that you want to see in this visualization. Upper ones should be density plots, it says. Lower ones should be these scatter plots, right? Smooth scatter plot. And the diagonal should be, obviously it doesn't mention it, but by default it becomes these density plots. Right? So that is it. What is alpha? So color by species. Use species to color. So you can see there were three species, so there are three colors in each of these graphs, and alpha is equal to 0.3. Just having a little bit of a pastel color makes a graph look good. Otherwise, it is too much in the, too bright primary colors, perhaps doesn't look so nice. So it is common these days to mute it down a little bit by adding a certain degree of transparency to the graphics, which is what I have done. Let's look at the next one. Now it should begin to look very familiar to you. What have I done? I've created the main item, which is the correlation plot. What is the correlation between each of these features? Right. Clearly, we can see that there's high correlation between sepal width and negative correlation, sepal width and petal length. We talked about that before. At the same time, there is a positive correlation between petal length and petal width. You remember that the Python pandas profiling mentioned about that. We can see it here. This is the code for that. Now, box plots, this makes the box plots. So, guys, what happens is that the first time you come into this field, there is a choice that I had. Usually, I would start the workshop by giving one-liner codes, one-line, two-line codes, and then making progress with it. What happens though is that here's what I found. As you make progress through the workshops and you go into a more advanced workshops, I noticed that people used to struggle with basic exploratory analysis. They were not very good at it in the sense that they could not do sophisticated analysis. I just recently held a boot camp for this data, pretty well attended boot camp. And when was it, Nisag? Around September, October, November, isn't it? Yeah. So in that boot camp, and it was remarkable actually to see that people were doing very well with the algorithms, but where they were struggling with or not able to do a systematic exploration of the data. And that's when I realized that first I need to train people into doing good quality exploratory analysis. See, guys, I lead a large data science team, and this is sort of a aside, but in the team, it's heavily dominated by PhDs and people with masters, like reporting to me, as I lead this research team. And you can see there are people who are very, very good with the algorithmic stuff and they'll do this. But sometimes, and it's quite odd actually, sometimes they'll come up with something in the analysis after doing a lot of computation and show it is there. And when you say, well, wasn't this obvious in the exploratory data aspect itself? Then they'll say, oh my goodness, we didn't do that. We didn't look at it. Why didn't they look at it? Because two reasons. People are in a hurry to get into the algorithms. And secondly, people are actually not well trained in data exploration. Whereas most of the, what I would say, intuition about that data comes from the data exploration. I always say that if you have spent a lot of time doing data exploration, when you go to machine learning, you're not flying blind. It's not that you're taking your airplane into a fog and you don't know which way you're going. You have a very directed approach to machine learning. You already have some intuition of what you're going to find, how you're going to make your predictive models, or what pattern recognition things you're looking for. You already work with strong intuition with that. So spend a lot of time in doing exploratory analysis. Now, looking at these things, I'm giving you guys this code samples and you can just directly use it pretty much. At the early stage when you're picking up things, there's a little bit of a way, I suppose in every field. I learned programming by using the monkey see, monkey do principle. I learned from the textbook, then I realized that all I had learned are toy examples and homework exercises in college. Right? Those are not long code bases. The solutions used to be 1 or 2 pages of code, simple code in undergraduate. And so after a little while, this was the first, second year of engineering, I realized that the right way to learn coding is to take a large code base and literally read through it, put breakpoints, debug through it, and then as you do that, make small improvements to it and do it by seeing how it is done. Right? So I call it the monkey see, monkey do way of learning, and that's how I learned it. Gradually, you pick up all the things that you don't find in books, essentially. Pick a guy who's very good with code, who writes very clean code, and then follow that person. Pick two, three such people, and you will find gems in their code that you wouldn't usually find in the textbooks. So, to do that, these are very simple code, of course. It's not reams of code. But at this moment, because you're new to it, if you are having a bit of struggle, just follow this. See that you understand it. And then whenever you need to, just refer back to it and use this code in your work. Are we together?
Also for the correlation plot, I'm having little difficulty in reading it. I mean, I need to read through little carefully. What's the best way to read a correlation plot?
The best way is it is a pair plot. So between two features, let's say there are four features here: petal length, petal width, sepal length, sepal width. Uh,
We have correlated only three. I don't know why, but yeah, we have you.
that is my mistake. You see the mistake I made? I should have said 1 to 5. It's my mistake. I'll fix that. Actually, good catch. In a hurry, I didn't include all four columns. I included only three. Yeah. So that is certainly an error here. But let us say that you look at the intersection of sepal length and petal length. The intersection is here in the center, isn't it? This color looks like what on the color scale? You would say that it looks somewhere like that, right?
Yeah, highly correlated. Yeah. Okay.
Highly correlated. Now, if you look at this guy, sepal width versus petal length, what does it look like? It looks like at the bottom of the scale, right? Rather strongly negatively correlated.
Okay. So you fix on one feature and then just read through the others to understand how it's related with others.
Yes, yes, yeah. And it's nice that we're working through this because I just realized that I had a bug here. I'll fix that, guys.
Okay. And is it common to omit the same thing? Like for example, sepal length versus sepal length is white because we don't want to just fill with obviously it will be highly correlated because it's the same feature, right? So you have just made it white here in this graph, correct?
The thing is that it is redundant to give. See, here's the thing. This is petal length, right? Compared to sepal width. But the reason it doesn't exist here is because it will be redundant. This
Okay.
would be redundant because petal length and sepal width, right, what is again here. So having it here does not add any value to it, right? Because we already have it here. Again,
Okay.
see what happens is I have taken pains to remove it. You notice that.
Yeah. Yeah, if you just do a normal correlated plot, I think it gives you everything. Yeah.
Exactly. And the reason you remove it is quite interesting, actually. People believe that you should not have redundant information. See, in programming, we say, right, do not repeat yourself, isn't it? It's somewhat like that in visualization. Do not waste ink. The reason is uh, any plot should be succinct, compact, and convey the maximum information. So redundancy doesn't help. And this is the pair plot. Actually, here the bug is I have said n is equal to 3. I should have said n is equal to 4. Number of colors. That's why one of them got it. I think I'll fix this. I think that's what it is. This is the histogram. And again, what I show is how can you put, suppose you have four plots. They all are related. Like, for example, four different features. How do I make a grid of them? Right? So you do that. And here I use something, yeah. So once again, plot grid. Stuff. Basics. Guys, any questions here? All of this code, guys, I know it is new, but are you feeling that with just looking at it, you get a sense of how it is done, and gradually you'll become familiar and start using it?
Yes, Asif. Yeah, it's very intuitive to follow right along. Yeah.
And this comes like that, guys. See, most of the things, see, textbooks are great for the theory, right? But the coding part, you have to see the code. That's why I'm opening up all this notebook. And learn by copying, first of all, literally monkey see, monkey do. But when you're doing it, you'll already think of, for example, this mistake of mine, right? So one obvious thing that you will do is obviously try to fix this mistake, isn't it? Quickly, because because you know that it was a typo, it was a silly mistake. And so you fix it, and then you suddenly realize that, wow, you did something new. And then in small steps, and before you know it, you're taking big steps. And after a little while, you have your own style of writing code. Yeah, and it is like that. This field is a lot of artistry or artisan work, craftsmanship, and each craftsman ultimately has his own style of doing things. There is something that is mathematical in this field, but there is also a lot of things that is very individual. I can often look at people's analysis, just read their notebook, and I can tell in my team who did it because I can sense the person's thinking style and a way of approaching problems. And becomes obvious pretty much in 5 minutes whose notebook I'm looking at. I don't have to see the author. So we all develop a unique style in due course of time. And it's a pleasure actually to have your own style. Like, for example, when you see my style of code, this is very elementary code, but you must already be getting a sense that it is slightly different from other people's style. So that's that. We look at the weather data set now, because that's where I emphasize the tidy data stuff. Now, and I'll use that. I'll stop here today with that, but let's take weather. Should we go with R or Python?
Yeah, we can go with R.
Oh, with R. Okay. So with R. With R.
But if we have some plans to show some things in Python, then I'm okay with that.
Both are equally good. So actually, let me start with R. Why not? What just happened? Okay. Yeah. Weather tidy data Python, weather tidy data, weather.html. I think this is R. Right. So if you look at R, do you notice that what do I do here? Can you, without reading the text, tell what am I doing here? I'm just
Reading. Oh,
six files of data. And this is real life, guys. Whenever data comes, you cannot expect all data to be nicely formatted in a single place. Data will come to you from many, many places. Right here itself, even at the same place, it's scattered across multiple files. Because the intention of the data generator was different from your intention. It made sense to the guy who created the data. It doesn't make sense for the problem that you are trying to solve. So the first thing you have to do is you have to wrangle with the data. You have to manipulate it and bring it to the format that you want. And once again, as I said, if you think of it as a grammar, as a systematic process, no matter what the data is, in very few steps, you'll be able to handle it. Now, I took this data, weather data comes in many formats. Most of them are already pre-formatted, but I deliberately took one in which the formatting would be very different from what we want. First of all, they are in different file. The other thing is they are in wide format. So we need to make it the way we want to make it. So this is all just looking at a preview. The city is fine. City has this county, latitude, longitude, very nice. But when you look at temperature data, you get a bit of a shock. Do you notice that I can't even, it horizontally keeps on scrolling. Do you see the scrolling, guys, in this table, raw temperature table? This is a classic signature that data is probably in what is called a wide format, not too many rows. Maybe there are too many rows, but too many columns. And when you look at the columns, you get a surprise. The columns are not features. What we want the features to be when we are looking at weather, we want the features to be temperature, pressure, wind speed, humidity, wind direction, things like that. But instead, it is actually the sort of what we call dimensions of the data, the context. Because for us, when we talk of weather, we talk of weather in Fremont today. So the context is a pair, city and time. So we would have ideally liked to see the first two columns be the time and the city. But instead, city is sitting there in the heading, in the columns, right? And the cells are temperature, which is nice, but the temperature, but no pressure, no nothing, right? So that is why the spreadsheet or this file data is scattered across so many files. So the first thing we will do is we will bring it into the tidy data format. Right? We will make it into a so-called long table, a table that looks the way we want it to look. And how do we do it? Once again, we bring in the tidyverse library. And this is it. We have to pivot. This is a concept of pivoting. Those of you who are used to either SQL or Excel, who do a lot of that, uh, may probably know about pivoting. But pivoting means just rotating, converting these columns into uh, uh, just all the column headers into a single column. Right? So you pivot and make it into this format. You leave the date time alone because that is why I've subtracted it. And don't include this in the pivot. And then exchange like the create a column called city, and the values that are sitting there, they should belong to a column called temperature. Right? This is pivoting, a sort of a way of rotating the data in some sense. Right? And also, while I'm at it, let me change the name from date time, which looks rather odd. This is in small letters, and we want our other titles to be in capital letters, so we might as well rename it for consistency. So you realize that this in one line of code or one statement, we are able to achieve quite a lot of stuff. And so I repeat the same process for each of the things, temperature, pressure, and all of that. And after that, what do I have to do? I can see whether it is in the right format. So I just sample into the temperature table. Does it look right, guys? The context is at some city, at some time, this was the temperature. Does it look like the right format? It looks like the right format. Right? Is the way we would like to think of temperature. Except that we want not just temperature, we want all the other things.
One question.
Yeah.
If what if there are more than one names to or values to in the data set? Can we do multiple times names to and value to? So
So
if there is a
that's through
city and say
level.
boroughs within a city and
Yeah, hierarchical data, right? Yeah, there are ways to pivot that, but it's a slightly advanced topic. It's the levels. How do you deal with levels and so forth? Simple answer to your question is yes, it can be done. Right. And those of you who are with SQL, how many of you are SQL gurus and realize that SQL also has a form of pivoting?
Yes.
Basically, pivot tables, right? It's creating pivot tables. This is it. So this is it. And so here we go. Then what do? We join. Join what is common to all these tables? Date, time, and city. Those are the two columns that are common to all of this data. So we can do a join on date, time, and city. And we do that, we get inner join. Join is a concept that comes from SQL. What it means is you're collating two tables where the context is the same and making a bigger table by joining the left table and the right table together along those columns. Now there are subtleties: inner join, outer join, left join, right join, and so forth. The basic thing is inner join is the simplest. Only rows which exist in both the tables, like the keys, let's say San Francisco and a particular date today. If it exists in both the tables, then only that row will be kept and the data from the two tables will be joined into the final table. Any context that's missing, or key that's missing from one table or the other table, uh, those rows are excluded. So that is inner join, and sometimes you don't want to exclude, you want to keep it. So then you do outer join, and sometimes you want to keep on the left table but not the right outer join, left outer join, and so on and so forth. So there are subtleties there. And obviously from SQL world, it may be familiar to many of you. But once you do that, you get this table. Now the beauty of having data in a tidy format is doing analysis on this becomes very easy. So for example, remember for Iris dataset, we found the median value, right? The same thing. How do I find, I just took median. Maybe I should have taken some other metric, max or, I don't know, mean or variance or whatnot. But it happens that I took median. In just one, again, pretty much the same code. Do you see that, guys? Weather data, drop NA. Actually, a few rows may have NA. Why are NAs problematic? Because you can take the median of 1, 2, 3, 4, but you can't take the median of 1, 2, 3 and a missing value. It gets a little bit harder. So often good to, or average, actually, median is still possible. Average is tougher. How do you deal with the missing value? So things like that. So, well, here it is. And arrange means to sort it by this temperature. Why did I choose to sort it by temperature? Just for fun, right? So for example, if I sort by temperature, I come to know which is in this data set, which is the coldest city, Minneapolis. Has anybody lived in Minneapolis or Denver? Was it? It's like you have been. Yeah. It's cold, isn't it?
It is really cold.
Yeah. Likewise, Denver and Seattle, of course. It's if it is not snowing, it's raining. That's a joke, right? And so let's see Seattle. Does it have a lot of humidity? Oh yeah, indeed. You see that the humidity of Seattle is more than the humidity of the other cities in the sample. And so this is doing it with R, but how is it to do with Python? Let us look at the Python.
So when we have a lot of missing values, the way we have to substitute, is it part of a sampling technique or what's it called?
Value, how to handle missing value is actually an important topic. When you come to the boot camp,
Okay.
it's a topic in itself. So I'll give you a preview of it. See, if values are missing, if you're rich with data, right, and the amount of missing values are not too many, you say, oh, I don't care, let me drop the rows. But suppose, you're talking about, let's say that disease problem I told you. Most people are healthy in a million rows. You have just 4 or 5 data sets which refer to some rare disease. But in those 4 or 5 data sets, you realize that some columns are missing. Right?
Yeah.
You can't throw it away. What do? Well, you impute a value. You can either take some sorting and for example, copy the value of the nearest neighbor, right,
Okay.
over below. You can put an average value of that column there, right? Or you can even interpolate the value. You can do a exercise to guess what the value should have been, right? Or you can literally do a machine learning exercise to predict the value. Right? So there are many, many techniques that you use to fill missing values. And again, now you're getting into the sort of things that you'll face in the real world when you face this situation. And a lot of those real world things will come to. See, guys, here's the thing. At this moment in the workshop, we are focusing on the core concepts of machine learning because it's the intro. We want to lay the foundations. So exploratory foundations is done, regression is done. We'll do classification and regression, but it's just the start. A lot of the practice aspect of it, you will do when you, assuming that you do come to the boot camp. There, it is a pretty good grinding. You'll be here from 10 in the morning till midnight, doing nothing, but practicing, trying out, doing analysis on data sets. So then,
What is the boot camp called? As of?
it's literally called the boot camp, right?
Oh, just the boot. Okay, it's called boot. Okay.
There are two versions of it. One is with on deep learning, and one is on everything but deep learning, the structured data. Right? So split it up. There's one for structured data, one for like actually split it out like that. Structured data, image processing, you know, convolutional neural nets, then natural language processing, time series. So the last three are mostly deep learning related. The first one, which is the core one, is everything that the broad spectrum of machine learning, getting the practiceness or the industrial experience in that. We'll take a lot of data sets and morning to evening we'll just practice. And you'll learn other things like how do you tell a story with data? How do you present it to management, right? When do you know that you have a result? When do you know you have been fooled?
Okay.
Things like that. So you'll get a lot of practice on that. But again, let's learn to walk before we run kind of thing. So at this moment, we are the early. We'll come to that. Right. So how do we do it in Python? By now, you know that this is going to be exactly the same. Reading the data, this almost looks the same, isn't it? If I remove the PD and say read.csv instead of read_csv, it would become R. Do you see that, guys? It's that close. Very small cosmetic difference in syntax. And here you do describe, there you do summary. Data manipulation is exactly the same. So we pivoted there. You can use pivot, but melt, I used melt here, which is very useful. So here you see me do that. Why am I doing it twice over? Oh, I just showed that you can do it in two ways. You see the two different syntaxes? They both do the same. You can call the melt on the data frame itself, or you can do pandas.melt and give it the data frame. Once again, you have to give the columns, city and the temperature, the attribute column and the value column. After that, data becomes like this. The rest of it is very simple. What will we do? We'll do the same pivoting on the rest of the table. And after that, we'll do the join. Does this join look almost the same? The only difference is that there in R we say by and in Python we say on. In Pandas we say on. Other than these minor cosmetic differences, they all look the same. Here we get data by all of that. Now that we have
Is this inner join or out by default?
yeah, by default it's always an inner join. I think I'm pretty sure it is just an inner join. But in case I'm wrong, let me know. You see, when you do outer joins, you have to explicitly say so. So there we go. Let's clean up this. Now, what do we want to do? We want to generate the summaries, right? Let us generate the summaries. How would we do that? Oh boy, here is data. If you want to look at data, so here's the thing. Once data is in a tidy format, see how easy it just becomes to do that. Suppose I want to filter the data only to San Francisco. Here it is. Right? If I want to sample a few rows, suppose I want to find the median, again, group by and median. As simple as that. The syntax in Python is the same number of lines of code, more or less, as in R, almost similar syntax. You do that. And this is deliberate, guys. People, if you follow a specific grammar, like a tidy language, tidy data format, then whatever language you choose, the code will look more or less the same. But the interesting thing is that you can systematically manipulate or data or wrangle with data and not feel that, oh my goodness, I'm lost. How will I deal with it? Just follow this process. And this process, by the way, the book that you have, amongst the textbooks, the practical book that you have, Pandas for Everyone talks about it. And the R book talks about it a lot. Actually, the R book does an exemplary job of talking about it. And I would suggest read both. You'll get a good review of the exploratory data analysis. So guys, it's 8:40. We have 20 minutes. So I'll just run through this code a little bit faster, perhaps. Oh, where did this go? Yeah. So we can go from here. The rest of it, I don't think I would like to. Oh, if you guys want to see something that I just added to your, I don't know if you saw the California data set. So let me show you the California housing data. It is there in your notebook. Once again, by now this should have become cliche. You're already good at doing it. How do you draw maps? It's very easy to draw maps in both R and Python. They both use something called the leaflet library, and Python's wrapper is called Folium. You can write code in Python, and in one line of code, as you can imagine, your maps will show up, as you can see here. So then this is a scatter plot of the data. Areas which are expensive are heavily marked. Median house price is high, is heavily marked, like marked in dark red. And less expensive houses are, as you can see, light colored, yellow colored. And the size of the bubble is the size of the population there. So obviously, one thing you can see from this graph is population centers tend to have the most expensive houses, which makes sense. The most expensive houses are there in the cities. San Francisco, for example, itself is a prime case where housing is very expensive. And now I have put just these two side by side, scatter plots and so forth. Yeah. Then how do you do the histograms? This is it of each of the variables. Now, when you see variables like this, you look at data, whether it is symmetric or not, and you observe what is going on. This data is bimodal. Do you notice that housing median age? You can literally see housing booms isn't it? Phases in which a lot of houses were constructed. So this data is from 1995. So you can see that in 10, 15 years ago, in the 1980s, there was a massive house construction boom in California. And then 35 years before that, that makes it 1960, there was a huge house construction uh, boom at that time, right? So you get a sense of what's going on, the history and so on and so forth in the thing, right? Well, if you look at latitude, why do you think there are two bumps here? Can anybody explain? Why is it bimodal like this in latitude? Anyone can guess? What do these two things represent? And
Yeah, and
The concentrated of the houses in a particular area.
yeah, look at this. Look at this latitudes, guys. Los Angeles is one latitude, low down, and at a much lesser latitude, at latitude of 300, is San Francisco. So you do expect two bumps, and in between is the empty Central Valley, isn't it? A much less populated Central Valley region and the coastal regions. So you do expect this becomes even more clear here. See, one population center is here, another population center is here at latitudes 300 and approximately a little more than 600. See, is that true? So, well, I think the latitudes have been rescaled to, what is it, 34 and 38. I don't know what just happened. But yeah, you see two bumps here in these two areas, right? So I think they have subtracted some amount or something like that. So likewise, longitude, right? You'll see two bumps because if you look at the cities, the longitude of this uh, San Francisco is here and LA is here. So you expect bimodality. So it helps to just look at the data and see, is it making sense? Because if it is not, it means that you have a bug in your code. You need to do something better. You notice that there is a skew in the income. What does it show? This is what you would say, sort of like a log normal distribution almost, or a Poisson or something like that. Skew, right skewed distribution. I don't know which one would fit best. It's right skewed. This is also right skewed. But you notice an anomaly. There is suddenly data seems to have a problem. At this value, there seems to be a lot of houses. Right? So either they are mansions at that house price point, or something is off with the data. And so you need to deal with that. You need to find out what is going on with the data and why am I seeing these pillars? Is it a mistake? Is it an error? Do I need to exclude this data or do I need to keep it? So those are things to do. This is another plot, very dense. This is the pair plot. What we did in R, we are doing it here in Python. It is literally that scatter plot, histograms, and there's density plots. It gives you a sense. So, for example, what is the relationship? You can't read it in this small font, but household and total rooms, right? Um, as the households increase in a block, so if there are more and more people living in a block, then the total number of rooms will increase. Is that something logical? It seems logical because quite likely, if in a single block there are lots of households, then typically each household needs about a 2 bedroom, 3 bedroom, 4 bedroom block. So the total number of rooms in that block will be proportional to the number of households. Right? Or maybe there's a high-rise building with lots of households in that and so forth. So you do expect a linear relationship, a linear positive correlation. Here also, total bedrooms and total rooms, of course, bedrooms and rooms are highly correlated. People who have a 6 bedroom mansion tend to have a lot of extra rooms also. And but sometimes you don't see any very strong correlation. For example, the housing median age and longitude, maybe a little bit of a relationship, but not much. Yeah. So it is good to just think about what this data means at each of the places. Right? And by the way, I've colored the data by how far it is from the sea or it is in the sea. It is not visible here, but if I were to increase the font size, then the color script, I don't know, even then, if the color would show up. Yeah, now. So that is that. And then just how do you make a single box plot or a thing? How do you make this violin plots? What violin plots show you is the densities, right? Sort of a smooth variation by household median income. So most people, for example, in this particular, people who stay within an hour of the ocean, they tend to have the median age seems to be in the late 30s, a little bit less than 40s, which is quite common. Right? See if it relates to your personal life. These are the box plots and so forth. So this is that, guys, and read it. You have it in your. Do you guys all have access to the notes? I've shared it with all of you. So the other thing that might interest you is I'm adding these notes to your thing. You'll see it in a bit. Uh, See, we have been talking about tabular data, but data these days have three or four more formats. One is fast emerging space in machine learning is called complex network analysis. See, the social graph, the Facebook graph, our connections, the emails that we sent and who we sent to and whatnot. There is a tremendous amount of information you can gather by looking at the network structure, who is related to whom, kind of thing. Or, the power grid, one from electricity is connected from here to there, and so forth. And so one of the emerging areas of machine learning, rapidly growing, is called network science. Very hot. And actually, it's the first time that I'll be introducing it in this workshop, simply realizing that it is a future. It will be more and more important going into the future. So one of the notebooks that I will be releasing in a little bit has to do with network visualization. So first is that what are networks like? And I don't know, can you guys see my screen?
Yes, As.
So it's a little bit of
Yes.
code, but I would say that ignore the code at this particular moment. These are some utilities I wrote, but the code at the end of it is very simple. This, for example, and this is just illustrative. It's a famous karate club example, a textbook example. It's like the iris of network science. Network. So this is friendships in a karate club. What do you notice? Do you notice that there are two pivotal guys, these two, who have a lot of links to other people? And other people have just like this guy only has two links and so forth. So this kind of a network is very likely to partition into two. And in fact, that's what's happened. This karate network at some point is split into two, right? Into two factions. So you can actually study that. You can see what is really going on. Or in a company, the way it is relevant is uh, see, in any company, there is a stated hierarchy. Somebody is the vice president. For example, I'm the vice president of AI and big data in my company. And then under me are directors and architects and so on and so forth, and layers of people. So you may consider that, okay, this looks like an important figure, but actually it isn't. In a company, if you really want to see where the influence flows, you have to see the communication networks. And when you see the communication networks, you'll find out who the real influencers are in any social body, whether it's a company or a social group or something like that. So there is an interesting story I like to say later on when we do network science. I'll talk about that story again. It's a textbook case. In one company, the management said that, see, whatever we try to tell the company, they don't believe us. Instead, we try very hard to be transparent, but there are all sorts of rumors flying around and misinformation flying around in the company. So one of the people, in fact, Barabasi, the guy who made the fundamental breakthrough in this field, he looked into the company's data. And guess what he found? He found that the hub, these people are called the hubs. There was a hub that there was a person who was more central in influencing the opinions in the company. And you would imagine he must be some very powerful guy, a director, VP, or something like that. Can you guess who he was? Anybody? Just throw a guess. You guys there?
Yes.
Any guess? Come again?
Like a janitor?
Yeah, pretty close. Actually, he was the printer and computer repair guy. So what he would do is
Oh,
there would be problems, IT guy, there'd be problems in different departments, and he would be going everywhere fixing problems, hardware problems. But when he was picking up gossip from one place and passing it to the next. So he became the propagation channel for gossips. And everybody reached out to him to know what they thought. They thought that he had the real information of what's going on. So now it's a very interesting question. Once you find out in your company, in this company, who the influencer is, what do you do? Do you fire him? Or what do you do?
You use it to
Use it, yeah.
spread your
What you
gossip.
do is, if you want to communicate information, you make sure that this guy understands and understands it correctly. So wherever he goes, he gives the right information. So that is the value of networks. And
Asif, how did they get the data that who
just
are the
look at the who's interacting with whom. You can get the metadata of emails.
the repair guy won't have any metadata, right?
Oh, yes, yes, because everybody was emailing him.
Oh, wow, okay.
So this is it. So here's the thing, guys. There are many networks. So here I wanted to illustrate the kinds of networks you have. This is what was considered the classic network, that you take n people, and there is a certain probability that the two of them will link. It's a 5% probability that any two people in the network will uh, become friends, let's say. Yeah. So how will the network look like? This work was actually done by a mathematician named Erdos. Ardos is famous, like one of the revered demigods of the field, so that everybody has a so-called Erdos number. Like you have worked with somebody who has worked with Erdos, your Erdos number is 2, things like that. So most people in this area, they know what their Erdos number is actually. So this is the Erdos of Erdos fame, and he wrote a paper which, for the longest time, was perhaps the most quoted paper in the mathematical literature. And that paper was about this sort of graph, how the relationship forms. So you may say, oh my goodness, I never heard of Erdos, or I never heard about graphs being so important. But this is it, as we enter machine learning, you will find all sorts of gems sitting here in many areas. So this network is, if you notice, what I have done is I'm looking for which nodes are influential, or in other words, which have lots of links to it, edges to it. So what I've done is I've colored the same network here. I didn't get that. Could you try again? I'm sorry, guys. My cell phone Siri is picking up. Okay, so if you look at this graph, what I have done is I've color coded. Do you see this color bar on the side, guys? So light yellow means the point has very few edges out of it, links out of it. Very few people are linked to it. So you notice that these light yellows are all around the periphery. Then as it goes darker and darker, those are nodes with a lot of links to them out here, as you can see. So this used to be the graph theory believed for the longest amount of time. Somewhere around the turn of the century, there was a breakthrough. And so you can see that. This is the distribution of degree. Degree is the number of edges in a node. Degree distribution is there. Then at some point, influential breakthrough was made by Baravasi and Albert. Albert was a student of Baravasi. They together realized that real world networks, wherever you look, they tend to have a property called scale-free property. And physicists make a big deal out of scale-free properties. It so happened that he was a physicist looking at it. And so when you look at this graph, you may not, if you look at it carefully, you will realize that this graph is different from the previous graph. If you look at this graph, maybe it's not so apparent at this moment, but it takes some time to observe it. Look at this graph. You notice that no one point is sort of the hub, a strong hub from which many points come. Right? And it shows in this picture, in this. But when I color it, but when you look at this thing, the biodiversity graph, what do you notice? You can see the hubs, the strong influence points from which all other, like which have excessive number of lines or edges going out of it, isn't it? And when you do its degree distribution, you see remarkably that there are a few hubs which have as many as 80 degrees, 80 links coming out of them. And this is how the world is. For example, some websites are very popular. Some research papers are very popular. Everybody refers to those research papers in their research paper. Right? And this is the citation network. Then you have the web page network. Some web pages are, some sites are referred to by a lot of other sites. And most sites are, or most web pages or most research papers are, they have hardly any references. So this is realistically, and even this, if you look at the LinkedIn network, for example, it also shows a similar behavior. If you look at the number of followers of Bill Gates or something, it will be in millions.
So what was
Whereas,
the innovation which he did to make it
what,
such?
what's that?
What was the change he made to the earlier graph, like in his model, which
Oh,
made
I'll
it
talk
more
about that.
apparent?
So it basically starts with one assumption. It says that the probability of two nodes joining is not constant. It depends. Networks grow, evolve over time. So when a new node comes into a network, then it has a preferential attachment to a node that already has a lot of edges,
Mm,
a node to which other nodes are linked, right?
mm,
Which is common, right? If you in any social group, you notice that the person who is the influencer, everybody first links to that.
yeah.
So when you bring that, you automatically, the mathematics, when you grind through it, you will have a scale-free behavior. And you can see that. I have plotted it on a shell map, and you see the scale-free behavior of this graph. So anyway, this notebook, I'll give it to you guys at some point and add it to the notes. It is actually already there in the notes. Where is it? Uh, Hang on. Let me go to the PDF and share. And with that, I would like to end. It's 9 o'clock. Where am I? Let me share. Yes. So I'm giving you an idea of what is coming so that you watch out for it when I update this graph, update this notes application.
As if I access the notebooks through the Slack channel, how do I access it?
No, it is there as a Google share. So if you go and look at your emails, you will have received a Google share
Okay.
you will receive a Google share for the PDF, this PDF that you're seeing. Right.
Okay.
But the notebooks are there on the, so okay, let me show you. So first of all, let's go through the PDF. So you see that I have this section on networks now.
Yep.
So there I've given a lot of mathematical explanation, the set that you were asking for, right? I'm
Oh,
explaining
okay.
the theory. So for example, this, do you notice that? The scale-free dynamics and so forth. So because it needs explaining, a little bit of reading all these things. So background theory I've explained. And then I've gone into some very interesting networks. For example, how do diseases spread? These days, that's actually of paramount importance. We all are hiding in our caves, because there's an epidemic in progress. How do viruses fail? For example, if you have to, what are the vulnerabilities in our power grid structure? You guys probably know that at one time in Northeast, pretty much the eastern seaboard went dark because of certain critical grid failures, yes, substation failures. But how did this happen in a technologically advanced world? How did we end up with cascading failures? So you look at it, you can do analysis of a network and tell there are vulnerabilities in the network. That's a very interesting emerging area of machine learning. And I thought we'll start slowly. Here, we'll just do exploratory analysis, and I'll give you enough background. At this moment, we stopped at exploratory, but later on, we'll do much more deeper machine learning. Now, today, I didn't get a chance for the rest of the linear regression, etc. Perhaps the next help session will do that. I would like to show you now where do you see the notes? So let me stop sharing and share again the Slack channel. Share Slack application window Slack.
Show us the screen, Asif.
No, my screen is a high resolution screen, then you won't see.
Okay, we can see now.
Yeah. So you're seeing the Slack. So guys, if you notice on your details, so for example here, this is how you see your screen, isn't it? Click on details at the top. Do you see the top right? There's something called details. Can you guys see on your Slack channel something called details?
No.
Oh, in fact, okay. Open your own Slack because I don't think it is showing the whole window. And check if you see this details link. You can open up details of your channel. You see these details. Can you see it where my mouse is going?
Yeah, I can see it.
And then you go to the pinned items. What I have done is all my notes are there as pinned items. So somebody asked about the notebooks. Here they are. Do you see this? All these notebooks are itemized. Who was asking this question? I forgot. So guys, are you getting the answer? You see that all of these things are itemized. Even my hand scribbling lecture notes are here. So for example, the last lecture, here it is.
The network thing is not there though.
Network thing is not there at this moment. I have not uploaded it yet. So that data explorations notes, right, is an evolving thing. As we move along the course, I'll keep adding material to it. And hopefully, if we come out of this whole Corona thing properly, then I'll send that to the printer and you guys can get that book as a printed hardbound book, in color hardbound book, at whatever the printer charges, which should be $30–40.
Yeah, I think we wrote down the names like a few. I think during the boot camp.
Yeah.
The book.
Yeah. No, so I made a deal with Lulu, online printer called Lulu, and so they have agreed to print. And it's an on-demand printing. So let's say 15 people. I would imagine that about in our network, about 300 people will want that textbook. So specifically, we can order a print of only 300 books. It's a print on demand service. So this is it, guys. All the notes are here. You see that this, everything is here, right? The only thing not here is this thing, the PDF notes, right? And those are a Google share. I've already shared it with you. The YouTube videos, they are here. So for example, if you click on this, you can go straight to the YouTube. Are you, by the way, are you guys actually using the YouTube videos to review, or it is just a waste of because it takes me quite some effort to upload all of that. Are you guys actually using those videos? Anybody?
Yes, yes, Asif. At least I go back and re-listen some of the stuff. On the second or not from end to end. I know certain areas that I need to focus on, so I go through that.
Asif, the videos are very useful, Asif.
They are useful. Good. All right, guys, it's 9 o'clock. We have been having this session for 2 hours. Do you guys have any questions? Otherwise, we'll close and we'll meet on Monday.
Asif, I have a question. So the lab notes, right? Is it similar to the one that you shared in the previous kind of instance of this class?
Oh my goodness. The regression note I have not shared with you guys yet, right? Let me do that tonight. Yes, they're exactly identical. Okay.
And you were talking a lot about Python. So does this have a little Python? Because the previous one had R solutions.
No, it has, no, the last time I gave it, it was both R and Python. Your batch did it with both R and Python, Albert.
Okay, let me go back and see it again. Okay, then I should.
It starts with R and then repeats the example in Python. Now this time I'm going to do a different strategy because repetition makes it rather dull. I may alternate. One problem I'll solve in R, one problem I'll solve in Python. I might do something like that. So, but anyway, I'm not changing those notes. It is as it is.
Okay, thank you.
Longer term, I'll absorb it in this new format, the new data explorations book that I'm writing. But at this moment I don't have time. So those notes exactly as it is. So did you verify it is there in both?
Question for me?
Yeah, we can go and verify it is there in both.
Okay.
I'm also going there and looking at it. Words, words, machine learning. Anybody is missing basic material, guys? Let me know. Reach out to me. I'll take care of it. Lab one solution, macro solution. Yeah. So 29 pages. Model. I'm looking at this. Okay, maybe to your batch, I didn't give the one with both R and Python, but now it is with both R and Python. I'll add it. I'll upload it. Let me upload all of it.
Okay. Thank you.
By the way, guys, a general feedback. Are you guys finding this course useful? Like, do you feel that you're able to follow along? Is the textbook understandable?
When you say the textbook, the ISLR, right?
ISLR, yes.
Actually, it takes a couple of readings. I'm not able to grasp everything at one read, but definitely after the way you explain it is always better. Otherwise, I'm not able to grasp the concepts there just by.
That would be true. In fact, that's a general feeling. People feel that that book feels very dense till they have been through the workshop.
Yeah.
Trust me, by the time people go finish the intermediate, they begin to find that book too elementary. I've had people come to me and say, don't you think you should up the level and start with a more a deeper textbook? Whereas people who are doing ML100, the first one, for them, even this is a tough beginning.
Yeah.
They all of you will reach a level when you'll find that book too easy. So keep at it.
Okay.
All right, guys. So with that, I'll end it.
Thank you, Asif. Good night.
Thanks, Asif. Bye.
Thank you, guys.